Question number 33. In free space, a shell is flying with a speed u towards a large stationary plane along its normal. When the shell is at a distance L from the plane, it explodes into an infinitely large number of fragments that fly apart in all directions, such that the speed of each fragment related to the mass center is v. Find area on the plane in which these fragments are going to strike. So let's consider this is a fixed plane, and this is the location where this shell explodes in all directions, and the center of mass is moving with velocity u towards the wall, and then these fragments are moving with velocity v relative to the center of mass, and this L is the distance, right? So this is the figure I'm trying to draw with respect to ground. However, this velocities of the fragments have been drawn with respect to shell center. Now, if we are interested in finding the velocity of any fragment, so let's say this is the velocity of any fragment. That velocity of any fragment is going to be equal to velocity of that fragment with respect to center of mass. That means out of these velocities, v, plus velocity of center of mass, which is u. Now, u has a fixed direction that is normal to the wall. However, this v has a fixed magnitude, but direction can be any of them, right? So we will write this v vector plus u vector. Now this v vector has a fixed magnitude, direction can be any feasible directions, whereas this u is a fixed vector, and this vf will depend on this direction of v. Now we want this vf to be such that this theta is max, because when this theta is max, so we can find out up to which point the fragments are going to hit this wall or plane. Now in this plane, you'll find these fragments are going to hit in a circular fashion. So there is going kind of disk formation, and that disk area we need to find out. So we need to find out like if this is the radius r, so it's going to area is going to be pi r square, right? And we need to find this theta max. I further wrote is this area on the plane will be pi r square, where r is the maximum radius. So theta should be maximum. Yes. Now it will depend whether which magnitude is more out of u and v. So if v is greater than or equal to u, then you'll find let's consider this triangular law of vector addition. This is u, which is fixed, and this is vf, we are going to get it. This is theta, and this is v. V can take any of the orientations feasible, right? Now if v has more magnitude as compared to u, then you'll find this v can be plotted against u as well, right? So you'll find that this theta can be bigger, like even theta can go up to 90 degree. So if v is having more magnitude, so you'll find theta can reach up to 90 degree. If theta is reaching up to 90 degree, that means infinite point will be striken by the fragments. So if v is greater than or equal to u, theta max will tend to 90 degree or can approach to 90 degree. That means entire plane will be hit by the fragments. Now another case is going to be when v is less than u, that means u is bigger than v. In that case, this theta cannot reach to 90 degree, and you will find to maximize this theta, this v must be perpendicular to vf. Because if we rotate this v in certain other direction, so this theta will become smaller. Why? Because v has a fixed magnitude. So theta will be max only if the vf, fragment's velocity, and the velocity of fragment with respect to shell must be perpendicular. So I wrote over here, and then for theta max, v and vf vector must be perpendicular to each other. That means it becomes right angle triangle. Once it is right angle triangle, then we can say vf must be equal to under root u square minus v square. And since u is greater than v, that means it is a feasible or existing number, right? So from here we got to know what the vf is. We also can find out what this theta is, and this theta is max we are talking about. So this in this triangle, if you look this bigger triangle, tan theta is going to be r by l. Moreover, from here we can say tan theta is going to be v divided by vf. So both thetas, tan theta can be equated. So from here we are able to find this r, small r, which is the radius. R is going to be VL divided by VF, and VF is under root u square minus v square. So radius is VL divided by under root u square minus v square. This is the maximum radius up to which the fragments are going to hit. That means the area on the plane is going to be pi r square, which is pi into square of this, which is v square L square divided by u square minus v square. And that will be valid only if v is smaller than u, that means for this condition. And this itself says if v becomes equal to u or otherwise, then it will be reaching to infinite. So there are two cases. In one case, entire plane will be stricken by the fragments, and in the second case, this will be the maximum area that will be stricken by the fragments. So this is how we can give our answer. Thank you.